Hello everyone, welcome back to Data Science tutorial series. Today, in today's video, we will talk about feature generation and extraction. In this, we will cover data sets and features, feature generation and feature selection. These three topics. So let us get started. First of all, we will understand what is feature engineering. So feature engineering is the process of transforming raw data into meaningful features that better represent underlying problems to predict models, improving overall model performance. So in feature engineering, we are having two parts. First, we have feature generation, and second, we have feature selection. As we have seen, we will transform raw data into meaningful features. Okay. For what purpose we will be doing this? To represent underlying problem to predictive models. Then it will improve the model's performance. In feature generation, we will create new features from the existing raw data. And in feature selection, we'll choose the most relevant features for training the machine learning model. Then next, we will talk about the data set. So what is data set? Data set is nothing but a organized collection of specific data processed by program to generate insights. This is nothing but a data set. It involves large number of data points grouped into single table. It is used across nearly every industry today for analysis and decision making. We know that forms of foundation on which every machine learning is trained and evaluated. So dataset is the basic thing for machine learning model and based on which we can train and evaluate the model. Just consider the table which is available on the right hand side where we will have ID, age and score. So here rows are nothing but a samples or also called as records in the data and the columns are called as features or attributes from the table. Now let us understand the components of a data set. First component is feature that we have seen. Feature is column or we also call it as a variable from the table. Input variables used for analysis are nothing but a features. So example, age, income, purchase history. These are the examples of features. Then next is a target variable, which is also called as label or output. So it is the variable to be predicted from the input variables. Example is churn status in retention modeling. Then next we have samples. Samples are nothing but a records or rows in the table, which are also called as instances. These are individual data points. So each row represents one customer, one student, depending upon the table. Then next we have metadata, which is nothing but a descriptive information about the fields in the table. So this is additional information about the data set like data types, missing values, and collection methods. Then types of data sets. So first we have structured data, which is tabular format data uh, available in rows and column format. So examples are CSV, SQL tables, and Excel. Second, unstructured data. Uh, it is the data which is not available in rows and column formats, and it is not tabular data. So in this, we are having examples like text, images, audio, and video format of data. It requires pre-processing for analysis. Then next we have time series data, data which is available in sequential format with timestamps like stock prices, activity logs. This type of data can be time series data. And then we are having graph or network data. So data which is showing relationship, which will be representing the relationship among the different data points. So social networks, recommendations, this format of data is nothing but a graph or network type of data. So these are the types of data. Then let us consider an example of data set related to student performance. So this is the table, and in this table we have different features: roll number, age, gender, study hours, attendance, test preparation. These are input features. Up to this, we are having these input features, and this is output feature, also called as target variable or label. So math score is a target variable or output variable. Based on these particular records, like we have three records here: age, gender, study hours, attendance, test preparation. Amongst these features, we need to identify what are the features which are responsible for our output variable, value of output variable, that is math score. So we will break down these features. So first of all, what are the numerical features in this table? So age is number, study hours is a number, sleep hours and attendance is a number, format of data, that is numerical data. What are categorical features? So categorical features are like gender, where we have male, female, these categories, and test preparation, that is yes, no form, that is also categorical type of data. Then our target variable, math score, or any kind of subject's score is nothing but a your output variable. Again, it is of type numerical. This is number format of data. Now, we need to understand why data sets matter in data science. So, there are a few reasons. Like, first, training machine learning models. So, used to teach algorithm patterns, for example, predicting customer churns. So, whenever we want to train the machine learning models, data set is an important entity, we can say, for training. Second, exploratory data analysis. For this phase also, we need the data sets, which where this EDA process will help us to uncover trends, outliers, and relationship in the data. Again, decision making is also based on the data sets that are available. So businesses use data set insights to improve the strategy. Like in case, for example, retention campaigns can be run by the business or industries based on the data sets. So what are different publicly available data sets? So to interact effectively with datasets, many universities and organizations publicly release the data for research and practice purpose. So first we have UCI repository where we will get the different types of datasets from different domains. Again, second example is Kaggle, which is community platform hosting competitions and open datasets. The next platform is a GitHub. Developers release ready-to-use datasets for practice projects on the GitHub. So these are the publicly available uh, platforms where datasets are available, and we can use those datasets in our projects. Then the next part is understanding features. So the measurable building blocks that power every model. We need to understand what feature is. So when we try to define the feature, it is also called as variable. Already we have seen attribute or column in the data set. It is an individual measurable property or characteristic of the data being analyzed. It is basic building block for the data set. Just like few examples are there, age, it is numerical type of feature, gender, categorical type of feature, blood pressure, cholesterol level. So these are the features which are available in healthcare data set, that is patient medical data set. So we can say these all these features are relevant to the patient. Feature versus target variable. So features, that these are nothing but a input variables. These are used to predict an outcome. These are also called as independent variables in the machine learning or data science terminology. Examples are like we have previously considered the student performance data set, where we were having different input variables. In that, one of the variable is study hours. So this type of variable can be used to predict the math score. So features predicts the target, that are nothing but output variables, which is also called as outcome being predicted, also called as label, and it is also called as dependent variable. So target variable will always depend on input variable. So example is math score is the variable which is dependent on different input features like study hours, sleep hours, attendance. This kind of input features can be used to predict the target variable or dependent variable. Then types of features. So we are having different types of features. First, we have numerical features, categorical features, ordinal, text, and time series features. What are numerical features? These are available in number format, also called as quantitative features. Examples are age, study hours, temperature. So numerical values, basically. Categorical, these are also called as discrete groups and also called as qualitative type of variables. Gender, test preparation, type of disease. So this can be categorical type of features. Then ordinal, so categorical with order. So we have educational level like from higher secondary to bachelor to PhD. So there is a order, and again type of variable is category. Then text is nothing but a unstructured string, student essays, product reviews. So this is textual type of data. Then time series, which is based or dependent on the time, like daily stock prices, heartbeat readings. These are the time series features. So these are the different types of features. Those are available. Uh, those can be available in any type of data sets. Then next, why features matter? So there are different reasons why features are important in our data set. First, it relates to the model performance. Better features lead directly to the better predictions, which will improve the performance of your machine learning model. Second, interpretability. Well-chosen features help explain why model makes it decisions. So models will be able to interpret why the particular decision we have taken based on the features. Next, efficiency. Irrelevant features increase the noise and computation time. So it can, if we use irrelevant features in our data set, so it will reduce the efficiency, and again it will reduce the, or it will lead to the poor prediction. Now we'll talk about real world example of data set and the features and target variables. So the example is predicting house prices. Here features, that is, we are considering as a X, and target we are considering as a Y. So X is talking about input features and Y is talking about output features. So here if we want to predict the house price, so here output variable is price of the house that we want to predict. So what are the input variables that we need to consider? So for related to that particular house, number of bedrooms available, location, square footage, then how many bathrooms are there, how many galleries are there. So these are the examples of variables, input variables, which are responsible to predict the price of the house. So in this way, we can have a data set of different parameters of house, and based on that different parameters, values of parameters, we can predict the output variable, which is nothing but a price. So this is one of the example that we consider. Here again we can say X is a your independent variable and Y is a dependent variable. So value of Y, that is price, is dependent on the value of this particular input variables. So every parameter can contribute to calculate the price of house. Then next part, motivating application. So we will take an example of customer retention data set, predicting who comes back to the particular product to purchase the product. So when we talk about customer retention and customer churn, so customer retention is nothing but a maintaining the existing customers. Retention rate is percentage of customers that stay with you within specific time duration, we can say. What is churn? Losing an existing customers means customers will be leaving or going away from you. Churn rate is the percentage of customers that leave within a given time. So next we will try to understand one case study, that is example of chasing dragons app. This is one of the mobile application which is available. We can download. It is one type of game, we can say. A mobile app charges monthly subscription fee. It is having some subscription fee with revenue increasing as more users sign up, the revenue will increase. But there is a problem. Only 10% of new users return after first month. Those registered from those, only 10% will return in the next month. Retaining the existing users is generally cheaper than acquiring new ones. And the goal is predict if new user will return next month based on this month's behavior. So what we expect that if we are building any app, so users will continuously visit to our app and should register and should not go back or should not avoid to log in our app. We want to predict whether based on the behavior of customer in that particular app, whatever activity he is performing, whether that particular customer will return or again subscribe in the next month or not. So the thing is that based on the data set, we can predict these things. But first of all, for that, we need to create or generate the data related to the customer and related to again activities of the apps. So we know that only 10% of new users return after first month. So this is numerical thing, 10% data. And again, user will return or not. Okay, so that is categorical variable. So our output variable is categorical here. So we will first of all choose logistic regression, which is classification model for prediction of whether that particular customer will again subscribe or not in the next month. So now we will try to identify the features based on the user's behavior. So user behavior will be recorded for first 30 days after sign up. So we will log every action with a timestamp for the user. So these are the raw event log, like this is timestamp and user clicked on level 6. This is timestamp slew a dragon, timestamp earned 22 points. So every behavior of the user will be recorded as a user is using that particular app. So it will ranges from thousands of events to just few per user. So there will be different logs which will be generated, and from these logs we can create a feature table which will be having rows. Those are users, which will be having column. Those are features. So here we can say generation of table is nothing but a we are generating features. In this way, we can generate the features related to the particular activity log. So this phase processing logs into structured data set is known as feature generation. For feature generation, the team of data scientists will do brainstorming based on the features. So team can include game designers, engineers, statistician, marketers. Those will collaborate to identify the relevant features to predict whether that customer will retain or not. So what are the features? Those can be brainstormed. Number of days the user visited in the first month, amount of time until second visit, number of point on day j for j is equal to 1 to 30. So 30 separate features will be identified, total number of points in the first month collected by the user. Did user fill out their profile completely? Yes or no? That will be categorical again. Age and gender of the user, screen size of the device. So these are few tentative features. Those can be generated, or we can say identified by the data science team. So here we need to note that redundancies and correlation between features are expected and that are allowed actually in while generating the data. So in part 3, we have talked about the motivating application where we can use the particular scenario for feature generation. Now we will in part 4 talk about feature generation, uh, which is nothing but constructing new meaningful features from the raw data. So what is feature generation? Already we have talked few things, but again we will just go through. Feature generation, it is also called as feature construction. We will construct new features, and feature extraction also, where we will transform raw or existing features into new features that better relate to the target. So once we identify the number of features, what we need to do? We need to extract the relevant features related to our scenario only from the existing. So for that, we use this strategy of feature generation. What are the different points we need to conduct? So first is mapping. Apply function like log to feature to reshape its distribution. Second is multiplication. This function we can conduct. Combine two features like is price and quantity, and we can create new feature that is revenue. Then addition, sum multiple related features into one aggregate feature. So we can also have the feature which is aggregation of different multiple features which are related to that particular feature. So this is nothing but a feature generation step. Feature interaction. So there two or more features can interact with each other if their combined effect is greater or less than the sum of their individual effects. So interactions with 3 plus features are possible but tend to show diminishing returns. Now, often these things are overlooked. It assumes that model will learn features relationship on its own. So due to this, we will overlook that. Why it matters? New flexible features enable simpler models. Those models can be faster to run, easier to maintain. That's why we need to check whether there is an interaction in between those features or is there any relationship between those features which are available in the dataset. Then categorizing the information for feature capture. So we can categorize into different scenarios. Like first we have relevant and useful, but impossible to capture. Relevant to useful, possible to log, and you did it. Relevant and useful, possible to log, but we cannot do that. Not relevant or useful, but logged anyway, unknowingly. Not relevant or useful, and never captured or considered. So these are the categories of the information from first relevant and useful to not relevant and not useful. So these are the categories those can be used while we are capturing the features. Then next part 5 is feature selection, which talks about the choosing the most relevant subset of features from the given data set, and we will see how we can select the features. What it says, it is the way of selecting subset of most relevant features from original feature set, that is original data set, by removing redundant, irrelevant, and noisy features from the data set. Now consider a scenario we have here. So we are having different features like age, income, city, device, session time, ad clicks, and gender. Now these are 6 to 7 features, but from those features we can select the relevant features based on our problem. So like consider age, though those features which are highlighted with the different color, age, income, session time, these are relevant for me. So those features will get selected and other features will get discarded. So that is carried out under the feature selection. We know that feature engineering mainly consists of two parts. First is feature extraction and second is our feature selection. It is very important to talk about why we need feature selection. So the reasons are given here. First reason being is a dimensionality reduction. So when we talk about feature selection, we are only considering relevant features and we are discarding the irrelevant features. So we are automatically reducing the dimensions. So high dimensional data is overfit and increased computational complexity. That's why dimensionality reduction is very important. Next, we will get enhanced performance by removing the irrelevant features or redundant features, which will improve the accuracy and generalization of the model. So, whenever there are less features, it will give us reduced training time for the machine learning or deep learning algorithms. So, fewer features means faster the training and practically for large data sets. It will avoid the curse of dimensionality. It will prevent sparse, hard to model high dimensional feature spaces. So that's why feature selection is very important phase in data science. We have two very important categories of feature selection techniques. First is supervised and second we have unsupervised. Supervised considers the target variable used for labeled data sets and unsupervised ignores the target variable used for unlabeled data sets. So supervised and unsupervised, both the techniques are available. We will use supervised for labeled dataset and unsupervised for unlabeled datasets. Three core approaches are there for feature selection. First method is filter method we can use. Second wrapper method and third is the embedded method. So filter method is statistical measure independent of the learning algorithm. Wrapper method treats selection as a search problem using the model itself. An embedded method, feature selection built into model training process only. So these are the different techniques those can be used for feature selection. So first, wrapper method we have. In this method, selection is treated as search problem and different feature combinations are made from the features those we have collected. So evaluated and compared also, and then training the model iteratively on each subset. What are the different techniques those involve? Forward selection is one of the technique where we will start with the empty. We'll add feature one by one, add one feature at a time until stopping criteria is met. Second method is a backward elimination. What happens in this method? We will start with all the features collectively, remove the least important one in each iteration. So every iteration will drop the irrelevant feature. Then exhaustive selection method, evaluate all the possible feature combinations, thorough but it is costly. Then recursive elimination method, rank features, iteratively remove the least important until target count is reached. So there will be target count. Based on that, we will remove the least important features. And there is a ranking method which is used to rank the features in recursive elimination. Then the next second method we have is a filter method. It is the method where features are selected using statistical measures. Already we have talked, independent of the learning algorithm as a pre-processing step only. So it requires low computational cost and does not overfit. What are the different techniques or methods inside this filter method? Information gain. So it will measure the reduction in entropy that feature provides the target. So entropy is very important to calculate the information gain. So it will measure the reduction in entropy. Then next type of method is a chi-square test. So it will test the relationship between categorical variables using expected versus observed values. Then the next method is feature score. where ranking method will be used, which will rank features independently. Larger the score means the better the feature. Then missing value ratio, we can use this technique or method, so which will drop the features whose proportion of missing values exceed the threshold value. Then next embedded method we have. In this, it combines advantages of filter and wrapper method. Both the methods will be used. So we can say it is hybrid approach by considering feature interactions during the training. So fast, iterative, and more accurate than both these filters. There are two methods. First is the regularization, which will add penalty to model parameters like lasso and elastic net. These are the methods, and zero coefficient features are dropped here. Tree-based methods are used where random forest and gradient boosting are the most used features. This will rank the features by importance to the model's output. So in this way, in all the three methods, we can uh, use these methods for feature selection. So how to choose a feature selection method that we need to discuss. Here, if you just see, we will identify the type of input and output variable first of all, and the right statistical measures follows from that only. So input variable, if it is numerical and output variable is also numerical, then recommended technique is Pearson's, yeah, or Spearman's rank method. Whenever input variable is numerical and output variable is your categorical, then we can use ANOVA or Kendall's rank method for feature selection. Whenever input variable is categorical and output variable is numerical, then we can use Kendall's rank or ANOVA. And whenever input and output both the variables are categorical, then we can use chi-square test or mutual information. So in this way, we can choose the feature selection method based on the type of input and output variable. So now we will talk about the key takeaways from this session. We have talked about the feature engineering, so which is nothing but a generation and selection, feature generation and selection, which is heart of predictive modeling. We have talked about the data sets, which organize the samples that are rows and features that are columns around the target variable. We also talked about the feature generation, which constructs new signal or data from raw event or behavior data. And we also talked about feature selection, which narrows the features to filter, wrapper, and embedded techniques. So these topics we have talked about, and now we will stop here. So in the next video, again, we will come with some new topic from the data science or some advanced topic from the data science. Thank you for watching.